Hello, good morning, good afternoon. I think it's almost afternoon. Good morning. Welcome to this session. It's great to see you all here and enthused from the early morning's discussions. My name is Anna Wellenstein. I am the Regional Director for Sustainable Development for the Latin America and Caribbean region. It's great to have you all here for this discussion on climate-induced migration. It's a big topic of interest for me. In Latin America and the Caribbean, we're particularly vulnerable to the effects of climate change with a lot of forced migration due to increasing dire circumstances in the home areas of much of the population. So climate change we expect to increase the frequency, intensity of extreme weather events that we've already seen a great deal of in the region. Fires, storms, flooding, landslides, drought, many are being displaced from their homes, but it's not only that, it's also the slow onset effects that we're really expecting to cause permanent migration in the region, both internal within countries and at least to start with within countries, but we expect more international migration as time goes on. We have a flagship report called the Groundswell Report, and it estimates that internal climate migration may reach up to 216 million people by 2050 due to slow onset climate impacts. And so for us in the Latin America region, this means about 17 million people, or about 2.6% of the population of the region, displaced by climate change. Some of our recent work suggests that many of these migrants will be indigenous and Afro-descendant communities that are already greatly disadvantaged. In Honduras, climate change impacts are expected to force between 40 and 56 million people to move domestically by 2050, most of them indigenous or Afro-descendants that are currently don't have any access to legal migratory pathways. This is in addition to the about 250,000 already internally displaced people in Honduras, the second largest number of displaced people in a country in the region. With high urbanization levels in Latin America and the Caribbean, the challenges of migration are bound to add to the challenges of poverty and urbanization, which is what we're here to talk about at this conference. Just to give you a little bit of flavor on some of the countries, in the Dominican Republic, recent work by our team suggests that internal climate migration is a lot about rural to urban migration, but also in some cases we're seeing substantial urban to urban migration. It's in part due to reduced agricultural output, reduced capacity for pastoralism, and water stress. So if you take cities like Santiago de los Caballeros, the second largest city in the Dominican Republic, it's expected to increase water stress, to have increased water stress due to climate change, and this will end up pushing people out of the city in the medium term. But on the other hand, if you look at the urban fringe of the capital, Santo Domingo, we're expecting to attract internal climate migrants coming from different points in the country. As more people move near the capital, the stress on local services will deepen. Providing quality services, housing, jobs for the larger population will become a bigger and bigger challenge for the country. So I'm talking about the challenges in Latin America and the Caribbean, but these same kinds of challenges are present to differing intensities in all the regions in which the World Bank works. That's why what we're doing here and what we're talking about in this panel is so important, to understand better the dynamics of migration into cities that are driven by climate change, who will be affected, where can we expect increased demand for services and infrastructure, where can we expect population to decline, what are the barriers for vulnerable households to move away and get out of harm's way? How can governments better support migrants to integrate into their destination cities or destination locations? These are questions in which we still lack answers, in which the answers will be really important for us to effectively support the governments we work with. So with that, I'm super excited to get some answers from this great panel that we have here today. We have a great lineup. Let me just introduce our keynote speaker, and then we will go on to introduce the others as we go step by step. Our first speaker today will be Mushfiq Mobarak, who is a professor of economics at Yale University. He has an amazing CV, so please go online and check it. I don't want to use our time to go through the long list of accomplishments, which will be obvious when you hear Mushfiq speak. So with no further ado, please, thank you.
Thank you, that was perfect. I'll put up some slides. So when I was invited to do this, so Harris asked me to come talk about migration, and I agreed because I felt like I was comfortable doing that. I do research on migration. And after I agreed, Harris says, oh, can you talk about climate migration? And it turns out I realized quickly that I don't know much, right? So then I've been doing some reading, and it was oddly comforting to find out that not many people know very much. And so that's why I'll abuse this notion of this being a keynote to give you sort of an overview talk on where I think the agenda should go, as opposed to what we already know, because really, researchers in the room, we should take note that there is a lot of work to do in this area, right? And it's also important, I think, for us to be clear to the policymakers in the room that the research basis of some of the claims that we're making are actually not that strong yet. So therefore, we need to identify, exactly what is the path forward, and that's how I'll use my time today. Okay. So the rhetoric around this is actually quite strong, often alarmist, that this is a looming crisis, that climate migrants might be security threats, and that type of language appears in the European Union's migration agenda. It appears in reports with the United States government, including the Department of Defense, from Australia as well, right? So I'll give you one or two examples of this. So this is a report written by the U.S. national security apparatus. And the title of the report is a security threat assessment of global climate change. And something that you see in the executive summary and all through the report are things about, what the threat assessments, like these are, they characterize these as in the immediate term, in the next 10, 20 years, that they're very high risk events. And in about 40 to 50 years, there'll be catastrophic events. Okay? And the language that you see about what exactly the threat is coming from, a lot of population migration, resource scarcity, human displacement, insecurity, conflict, etc. Right? And here's the map where they characterize how the threats vary across the globe. And a lot of it is in the global south. The colors in all of their maps are darker in the global south. And again, threats of large-scale displacement, migration, a lot of it interregional, but some of it also moving to the global north. Okay? Now, so those are, these types of statements actually are, I'm using one report, but they are omnipresent in the sort of the policy analysis of what's happening, what we think is about to happen with climate migration. But here's a sort of a perspective piece in Nature Climate Change published in 2019, that there isn't that much rigorous research, and there's a danger that migration policy will continue to be based on weak scientific evidence, and it reinforces the self-perpetuating myth of climate change migration. Okay? So essentially the problem is that we haven't yet had the ability to observe any of these movements that we're worried about, and empirically that poses a challenge for researchers, right? So we're trying to make predictions on something that might happen, and it's just that we haven't had the ability to observe those things, and so we're making inferences based on other contexts, right? Which may be related to climate change, sort of, for example, weather variation, but we also haven't had the opportunity to observe the types of adaptation that people may be able to figure out that could be migration, but it could be in many other dimensions, right? And, of course, innovation, the potential for human ingenuity, like none of that is directly observed. So that's basically the fundamental challenge here. Okay. So you see that the literature, when you look at when these projections are made, you see that the literature is quite self-referential. So there's like a cycle of citations, right? And ultimately, fundamentally, I don't think the data is there, right? So if you just look at the descriptive data, it seems unlikely. Like this is a pure sort of a stylized fact, again, published in Nature Climate Change, a different paper, that if you look at exactly why, data on asylum seekers, where they're coming from when they arrive in the countries where they seek asylum, right? Climate or weather seems to not have very much to do with it until now, okay? It's very clear that people flee violence, right? And you see this in the regional data as well, that when we see increases in asylum seeking, it you can identify exactly when and why this is happening, like post a crisis or conflict in Afghanistan, Syria, Iraq, etc. Right? Climate, weather is really not sort of the big storyline here. Okay? So now, let me move quickly to how we've been trying to make progress on this on the research side. There are quite a few papers, to the extent that I'll show you. There's now meta-analysis of the links between climate and migration. Okay? So here are 3 types of empirical approaches that have been used in the literature, and it came sequentially. So we started with cross-sectional comparisons between areas with different climates. So this is basically taking the globe or a continent and thinking about, like, what does productivity look like in one part of Africa versus another where the climate is different. Okay? So now, and that was essentially replaced by a lot of literature that was using panel variation, which is basically using within location variation in weather over time, right? So of course, generally speaking, for empirical identification, panel variation is often better than cross-sectional variation, but there is a trade-off here that I want to highlight, right? Which is that the disadvantage of the cross-sectional comparison is, of course, omitted variable bias, and it's fundamentally untestable, right? So if I'm comparing, different parts of Africa to make an inference, now if it turns out that the climate in Malawi will start looking more like Egypt, right? Of course, Egypt has the Nile and Malawi doesn't. And therefore, we cannot just say the productivity in Malawi will switch to whatever agricultural productivity is in Egypt right now. That's a clear problem with cross-sectional comparisons. But on the other hand, the one advantage is that agents who are living in a location for a long time would have already had the chance to adapt to that climate. So we would be observing their outcomes net of any kind of adaptation, right? Which is something that short-run fluctuations in weather using panel data is not going to get for us, right? So now the third approach, like moving forward from there, is instead of thinking about short-run fluctuations in weather, why don't we take long differences in the distribution of weather, right? The idea is that short-run fluctuations, people's responses may be fundamentally different from whatever long-run climate change variation might look like. So just as a simple example, if you have short-run water stresses, you could move towards groundwater irrigation. But if there is a new regime we're moving to with a lot of drought, of course, that's not going to be a sensible solution for that, right? So with the long differences, it's an improvement, but there are still concerns about this. So for example, let's say with long differences, we can properly parameterize what we think climate change will look like, right? But it's still the case that there's going to be endogenous responses in terms of migration. The composition of the population will change, which is not being observed. Or a recent paper talks about endogenous innovation as well by Jacob Moscona and Sastry. And that's going to complicate inference as well. Okay? So essentially, there is a lot of research that falls into these 3 buckets to the extent that there have been there's been a meta-analysis of the set of papers, and you do see estimates both all over the place, both on the positive and the negative side in terms of the likely displacement effect of changes in precipitation, changes in temperature, essentially weather variables, right? Okay, so now let me just end by talking about giving you 1 or 2 stories about what I think the path forward might be, right? As empiricists, we want to be able to say these things with a lot more confidence than we can currently say. I'm not too comfortable that we have a lot to say yet, right? With a lot of confidence that can guide policymakers on what we should do. It probably is a looming crisis, right? But we need to catch up with the evidence, right? So I think one possible path forward is that due to some rapid recent changes in climatic conditions, we're finally in a position to observe what is actually happening and how people are actually responding. So you see this in many different dimensions. There's been a 400% increase in tropical floods between 2000 and 2018, doubling the frequency of days that exceed 33 degrees Celsius, right? Urban extreme heat exposure, and then finally rapid salinity intrusion in the low-lying deltaic regions of the world, like in the Mekong River Delta, like in the Bengal Delta, in southern Bangladesh, southern Vietnam. Okay? So let me show you what I mean by actual changes that have been happening, right? So these are pictures of like a water index done by people in that field. And it's a change, and it's a change. This is showing a change from 1988 to 2019. Okay, so we haven't been able to net out sort of permanent water bodies here, right? Sorry, I meant hydrologists. That's what I meant by people in that field. But so we haven't netted out permanent water bodies, but you see clear patterns, like year to year, there's like sort of a creeping change. But over the course of like a 20, 30-year period, you see sort of discrete changes in the amount of intrusion of salt water, seawater, right, during the dry season. So these pictures I'm showing you are for the Boro season or the dry season in Bangladesh. So this is not flooding from the water that originates in the Himalayas, right? This is encroaching saline water, right? So that's led to like these small changes in sea level rise of about 7.9 millimeters per year over the last 30 years has led to increased salinity and increased brackish water in the areas that people used to grow rice. Okay? And rice is a thirsty crop, which is why, in Bangladesh and Vietnam, it's so productive for rice, right? Because we're low-lying, because I'm from Bangladesh, because we're low-lying, because we have frequent flooding, right? But rice really doesn't like salty water. Okay? So there's been a big increase in the farmland area with more than 8 decisiemens per meter of salinity in the dry season. And this has been encroaching more and more, further and further north. So now new sets of farmers every decade, right, are experiencing increases in salinity. Okay? So now what so something that we do know from the agronomy literature is that for different types of crops and even different crop varieties within the same crop, rice, right, the effects of salinity varies quite a bit, right? So on the graph you have there is all these coastal districts in Bangladesh and the amount of land that is now that now experiences water with salinity over this 8 decisiemens per meter threshold. And that's particularly bad for rice, and especially like the regular rice varieties that people grow. And even for the most resilient rice variety, the Bangladesh Rice Research Institute's invention, it's bad, not as bad. For wheat, it's less bad, right? So you can imagine that people are going to react to this by adapting, right? So what types of adaptation? It could be changing the crop you grow. It could be changing the crop variety you grow, right? But here's what's been happening. So this is what I mean by direct observation and what we can learn from it. So this is what that land used to look like, in the earlier period, in the earlier parts, like 20, 30 years ago. And this is what it looks like now. Okay? This is by design, right? So people are switching, but they're switching into doing something completely different, right? So it turns out rice doesn't like salt water, but shrimp and other types of seafood don't mind. And Bangladesh, the shrimp industry has grown about 500% over the same period. Okay? Now, of course, this is not like that's a form of adaptation, but it's not like we are, we just move to these areas and we're done, right? So there are some issues to consider. So I'll point out a couple, just because I'm pointing out these are, by the way, relatively open research questions. Exactly what the adaptation would look like, how successful it'll be, what will be the net effect on productivity, right? And what will be the effect on migration. So I need to bring this back to migration as well. So one issue that's already clear from this move from agriculture to aquaculture is that you have this new problem, a political economy problem of land consolidation, okay? And because the minimum efficient scale of an aquaculture farm, of a shrimp farm, right, is a lot larger than that of a rice farm. So rice plots in Bangladesh over generations have been quite through the process of land passing from parents to children, right? There's been plots have gotten smaller and smaller, right? But you can't really do shrimp farming that way. Okay, so now we have an opposite problem of we need some kind of land consolidation, and you can imagine there's a lot of difficult political economy issues to consider there as to, because our laws also have to catch up as to how easy do we make land reform? How easy do we make, this old move from like the post-colonial period when we were trying to get rid of big jamindars, right? When we actually have laws in South Asia against large land consolidation, right? But that's what the economic realities of today might require. So that's a set of issues that people do need to do research on. And I'll give a shout out to Islamul Haq, who just got a PhD with Matt Khan at USC. He's been looking at this problem. Okay? And a second issue relating to migration is that shrimp farming is a lot more land intensive and a lot less labor intensive than rice farming is. Okay? So what this will mean is labor demand falls because most of the people engaged in agriculture in South Asia, right, including in this part of the country, are landless. So they're supplying their labor on other people's farms, right? And so now labor demand falls, wages are going to fall. And so the people who were working in agriculture will have to do something, right? And that something might actually involve a lot of migration, a lot of out-migration from those areas. Okay? So it's most likely based on historical patterns that much of that out-migration will be internal rather than international. That shouldn't come as a surprise to many people in the room who have been following the migration literature. Across the world, there are, this is actually comparing a stock to just a 5-year flow, and even then, the 5-year flow of internal migration is many, many multiples of the total stock of international migration from most developing countries. Okay? So I'll end by saying, look, if this is, so in terms of path forward, there's basically 2 lessons that I want to share with you. One is that I think looking back at, say, weather variation, as we discussed, has some disadvantages, right? That's difficult to overcome empirically, right? I think we have a chance now, due to the blessing of climate change, that people are actually experiencing these changes, right? And we need to try and understand by directly observing their responses exactly what happens when climate change occurs. Like in Bangladesh, it's not like the movie Day After Tomorrow where overnight something will change. It's this creeping, increases in salinity due to creeping sea level rise year after year after year, right? And the second thing is that if you want to understand migration, right, the migration responses, we actually have a lot of research on migration that's unlikely to be related to climate change, just a lot of research on internal migration. And I'll just end with a couple of the lessons we have from that literature, which I think will be informative about understanding the potential for climate migration as well, right? So I'll give you 2 facts about rural and urban areas, that some of that migration may actually lead to new opportunities because across the entire world, I'm citing data from this QJ paper by Doug Gollin, David Lagakos, and Mike Waugh, right? A macro paper that collected micro data from about 80 odd countries and detailed micro data and looked at wages in agriculture, non-agriculture, urban, and rural. And they find that across the world, there's about a 350% gap. The average gap in that 80 country sample, 350% gap in terms of urban versus rural wages. You earn 3.5 times as much in cities compared to rural areas within the same country. Okay? So this may be an incredible opportunity. Maybe if migration occurs and people start moving into more productive places, right, and we facilitate that, perhaps we'll generate a lot of growth that way. Okay? Maybe this will be a blessing, and I wasn't just being sarcastic. This will be a blessing in that it will move people towards more productive areas, and there'll be better spatial allocation of labor to other factors of production. Okay. Now, a second fact is that this is really difficult to distinguish from climate-induced migration, is that there's a lot of seasonal, circular, regular migration that happens every year, right? Which predates our thinking about climate change. Okay? And that has to do with agricultural crop cycles, that there are some, poor areas that get extremely poor and labor demand goes extremely low during periods when you're just waiting for the crop to grow. So it's often linked to the pre-harvest lean period. Okay? And there, the policy implications and what we need to be thinking about, which also I think applies to policies in response to climate change-induced migration, is given these issues, should we be focusing on some job creation in rural areas where jobs are disappearing, right? Or should we instead invest in better urban connectivity? Right? Should we be connecting cities to rural areas? Because just because the poor people who are losing employment happens to be in rural areas doesn't mean they always need to be there, right? And the right policy instrument might be facilitating more migration and making the cost of migration lower, right? And there we actually have a lot of research. So people have been studying this question of why is it that more and more people aren't migrating? Given the, the 350% gap I just showed you, right? That suggests that there is a big puzzle there, right? That in spite of that gap, people aren't taking advantage of that arbitrage. Okay? So there we have lots of research on, say, the importance of migration cost. Sometimes people don't migrate because even though wages are higher, it may be risky in the urban areas. And sometimes people don't migrate for the converse, which is there are some amenities associated with rural areas, such as informal insurance, right? The risk sharing that they have access to that they cannot replicate in urban areas, right? Sometimes, those types of rural support programs can act as distortions to people's behavior, right? It keeps people in the wrong places because you need to stay back to take advantage of the public support that you might get that's place-based, right? And we also need to be thinking about the non-monetary cost of migration. It's not just physical costs, but it's also the case that it might lead to family separation, et cetera, right? And another set of issues that, this morning's panel talked about is the set of disamenities in urban areas, right? That may be keeping people away from places where they would be more productive, right? So that could be pollution, that could be these bad, the negative externalities Ed kept mentioning, right? That if we don't manage cities well, we're going to be, instead of all the positive externalities of innovation and ideas generation that cities bring, we may be just seeing a lot of the negative externalities of congestion and crime and housing problems and lack of sanitation, lack of water, et cetera, right? So those are the types of things that we need to work on. And I'm just saying that there is a literature that hopefully will guide our thinking around the policies in response to climate change-induced migration as well. Okay. Thank you very much.
Excellent. Thank you so much, Mushfiq. We have 2 more speakers and a discussant, so a lot ahead, a lot of new thoughts and additional thoughts, and hopefully some dialogue as well. Let me introduce our next speaker, which is Gharad Bryan, who is a lecturer in economics at the London School of Economics and Political Science. Again, another distinguished speaker. Gharad is joining us virtually. I want to check and see if we have him. Are you with us?
Hear me?
Yes, we can hear you. Perfect. Thank you very much. May I turn the floor over to you, please?
Brilliant. Can I just check that you can see some slides?
We can see slides. And we can see slides starting to move. So perfect.
Amazing.
Thank you.
All good. Thank you for inviting me. And let me just start by saying I'm essentially going to agree with everything that Mushfiq just said. If you know me and Mushfiq, might not be that surprising. So essentially, I see Mushfiq as having said 2 things. One is we need better data to understand climate migration, and I'll try to give you some data here. The second thing is that migration need not be thought of as a negative thing. And so I'll try to talk a little bit about one pathway to get the positives without the negatives. So I sort of think of this as moving beyond the displacement idea to seeing migration as a potentially positive outcome. Okay, and this is joint work with Robin Burgess, who's at the LSE, also Stefano Correa, who's at Warwick, and Jack Thiemel, who is a graduate student here at the SC. Okay, my slides aren't moving. Okay, so to start with, I just want to sort of share something that I guess we all know in the background, which is that much of climate change is a spatial problem. So this is a lovely diagram from a recent QJE paper by Tamara Carlton and co-authors. And this is showing predicted mortalities from increased hot days by 2100. And the thing I mostly want you to see here is that there's large spatial variation in what we think are going to be the impacts of climate change. This is across the entire world. And there are places here, obviously, that are predicted to have lower mortality and places that are predicted to have much higher mortality. This is a much worse diagram that we've produced of Bangladesh. but trying to show that this is true even within country. So this is predicted changes in crop yields by 2050, and the red dots are places where you expect very large drops in crop yields, and green places are places where you expect no drop or even moderate gains in crop yields. Even in Bangladesh, a country we think is going to be extremely badly affected by climate change, there are some green dots here. These tend to be slightly higher in elevation. So this spatial nature of the problem is both an opportunity and a threat. The opportunity here is there's a significant ability to adapt through migration across space. And that could come with all sorts of benefits, as Mushfiq has said, of people moving out of rural poverty into what we hope are potentially more productive urban and more enjoyable urban lifestyles. There's a threat, of course, which is if that migration isn't well managed and well understood. For example, if too many people move all at once, or if people don't move until it's too late, then there could be large negative outcomes of climate change. And if I talk to my students about what they think is the mechanism through which climate change may have strong negative impacts on human lives, it's through people ending up at borders en masse and what we all think will be the massively negative outcomes of that kind of outcome. Okay. So this suggests to me that we want to try to understand whether people are going to move across space in an orderly kind of slow trickle, or whether they're going to move in a mass way. And so there are many reasons to think that people might not move optimally across space. And we are going to ask a simple part of that problem, which is, do people know that they are going to have to move? Is it the case that a person who is likely to end up a climate migrant is already aware of that that's going to be the situation, such that they can make some changes? If they are not aware of that issue, are we able to give them information and help them to understand their situation? And if we give people information and we change their beliefs about climate change, does that lead to people deciding to change their migration intentions or not? And you'll see in this last question that this is partly what Mushfiq is asking about, which is to try to estimate the causal impact of changes in climate beliefs on migration, something that we've been very hard to, it's been very hard to do up till now. Okay, so I'm going to present you our answers to these questions. We're going to try and answer these questions in a sample of 7,000 households living in rural Bangladesh. What is the sample? We've selected some high impact villages and some low impact villages from a representative sample that was created by BRAC, an NGO in Bangladesh. We take a random sample of households in those villages, and we're simply going to ask some questions from household heads and also the partner of the household head if that person happens to be available at the time. What are my takeaways that I'm going to present to you here? They're going to be fourfold. The first is that respondents are actually direct impact pessimists. They understand that climate change is coming, and if anything, relative to consensus, they think it's going to be worse than it is, than we predict that it is. Second, however, people are what I will call in situ adaptation optimists. They understand that there are damages coming, but they believe that they can almost completely, or even more than completely, adapt without moving out of sector and without moving across space. This is Mushfiq's change to shrimp farming, and people believe this is going to be successful. Because of this, perhaps, migration intentions in our sample are very low. People don't see themselves as being likely to move across space. And perhaps because people already know climate change is coming, when we give them information about what climate change is going to look like, this has no impact on their beliefs or their migration intentions. So it's not the case that there's a simple policy thing here which is informing people about what's going to go on. Okay, so I'm going to talk a little bit about how we do come up with these four answers and show you some data. So the first question is, do potential migrators know what is coming in the future? So let me talk about how we do this for a bit. We're going to divide the area of potential impact into four parts. Why divide? Well, I'll talk about what they are and then I'll answer why. So The first is, what are going to be the physical changes? For example, do potential migrators know how many more hot days there are going to be in their region or not? Those are physical changes. The second is, do they understand what are going to be the impacts, the damages from those changes? For example, do they know that when there are an increase in hot days, there's going to be an increase in deaths, and do they understand how many deaths there are? Then we're going to ask about economic damages without adaptation. Do they understand how bad the economic damages are going to be for them? And finally, do they understand what economic damages are going to be in situ without migrating, but if they are allowed to adapt? The first two, at least, allow us to ask whether people are correct in their beliefs about what is coming, and the others are somewhat more speculative. The main idea in breaking this down is we can try to understand where people's information gaps are that may lead them to under-migrate and be left unprepared for the changes that are coming. Okay, how do we measure these things? Well, we measure physical changes as follows. We ask about two domains where we can have quantitative questions: hot days and floods. We first introduce to each participant a benchmark. We say that in 2020, there were X more hot days in your region per month than there were in 1990. This is to give them some sense of what the language we are using and hopefully calibrate what they're going to say. Usually, it's zero between 1990 and 2020. We then ask about future hot days. For example, how many more hot days do you believe there will be by 2050 in your location? And we then compare this to predictions from climate models. These again are down to the pixel level. They're around 50 pixels in Bangladesh. So these are fairly local predictions. So that's physical changes. For physical damages, we do something very, very similar. We can't benchmark. So instead, we just ask about crop yields and deaths. So for example, we have the first step is to ask a quantitative question. With 10 additional hot days, how many more people will die in a year? And we compare that to facts from the economics literature. For example, there are lots of papers or a growing number of papers on what is the causal impact of these hot days on deaths. For economic damages, we simply ask people, suppose you have someone who's earning 10,000 taka, I think it's a month, and they do nothing to adapt to climate change. How much do you think their income will go down? We then ask with adaptation. So imagine somebody who's earning 10,000 taka and they do nothing to change, and they are able to change and adapt to climate change, for example, by using different seeds, but they aren't going to move across sector or space. How much will their income change by 2050? And we also ask about the costs of adaptation. Finally, we ask about people's migration intentions. The goal here was to try to understand how much migration there is. And if we are able to change people's beliefs about migration, about climate change, do people's intentions about migration change? We ask both for the respondent themselves and their intentions for their children. So I've already said to you what I think are the takeaways. So let me just show you the graphs. These are mistakes in terms of how many hot days are predicted. So if you are 0 on this graph, you nailed what our model says is the correct number of increase in hot days in 2050 relative to today for your location in Bangladesh. The truth is, on average, there'll be 7.1 more hot days. A hot day is above 32 degrees when it becomes difficult to work. Overall, people have a mean prediction of 11.6 more hot days. So on average, they're pessimistic. They think that climate change is going to be worse than our models suggest. Although I will point out that there's quite a lot of variance in here. So there are some people in the tail who actually think there's going to be almost no increase in hot days. And there's obviously quite a lot of noise in the data, but on average, people are pessimists. They know climate change is coming. These are the damages that come from climate change. So on the left is crop yield. It's the same kind of idea where 0 is that you are correct or in line with the model we have for your location. And here again, the truth is that we predict there'll be a 1.8% reduction in crop yields by 2050 on average in our sample. But the prediction that farmers and population are making is 6.4% reduction in crop yields on average. So again, people are very pessimistic here. On the right is mortality mistakes. The truth is we expect 5 more deaths per 1,000 by 2050 because of climate change, and they are predicting 12 more deaths per year, sorry. So again, pessimism. So it seems overall our sample understands that climate change is coming and understands that it's going to be bad. What then are the economic losses? So the red here is beliefs about how much expected earnings will change without adaptation. So the benchmark here is 10,000. We say take someone who's earning 10,000. What will they be like in 2050 if they do nothing? And here we see that on average, people expect large losses from climate change. There's a strong mode here at about 5,000 taka, which means a 50% reduction in earnings due to climate change. If anything, again, that's pessimistic by 2050 for most of our locations. What's key here, however, is people believe that they can more than adapt to this. So the claim here, you see the large mode, which is about 1,250 taka, 10,250 taka. A large group of people are saying, actually, while there will be direct losses, we can adapt in a way that ultimately means we will be better off than we currently are now. So people are damages pessimists, but adaptation in situ optimists. We also ask them what the cost of doing that will be. Here they say there are costs of doing it. And overall, on average, people still believe that after paying the costs of adaptation, that is the cost of moving from a rice farm into a shrimp farm, that they will be better off by 2050 than they are now. Perhaps unsurprisingly, on the basis of this, there are quite low intentions of migrating at this point. So the blue lines here are the probability that you migrate yourself, and the green lines are the probability that you migrate, that your children migrate by 2050. We see that a full 70% of the sample say that they are almost surely not going to migrate. That's very low migration intentions. For children, it's a bit stronger. About 50% of the sample say that they more than 50% chance their child would migrate. But we still think this is quite low migration rates if we think that a large number of people are going to have to move out of these areas by 2050 or 2100. Okay. The next thing we're going to ask is, we wanted to ask, can people's beliefs be updated? So we wanted to give people information and see whether they change their views of climate change. And given what I've shown you so far, which is they're roughly right or pessimistic already, you might infer that this is not going to work particularly well. But what do? We give them some information based on climate models about what they should expect in their specific location in Bangladesh. Should they expect more extreme heat, more floods, lower yields, higher mortality, sea level rise, etc.? And we provide that to them in a document and explain it all to them. We have 3 different treatments. We want to say, these are the physical changes you can expect. Then we have a treatment where we tell them these are the damages that you can expect. And then we have a combined treatment. These are the physical changes in your environment you can expect, and these are the damages you can expect to your income. And we're hoping to understand where's the domain in which we can have the biggest impact on people's beliefs and hence migration intentions. What do we see? And again, I've already presaged this, is people already kind of understand what's going to happen here. So this is flood likelihood in 2050 in red, us giving them information about the physical impacts of climate change in their location, and expected damages does not have a large nor statistically significant impact on their beliefs about the likelihood of a flood. And remember, this is a reasonably large sample of 7,000 people. The same goes for hot days. These are expected economic costs. And again, we see nothing statistically significant, and nearly everything is extremely small, in line with people already having consumed this information. These are intentions around migration for yourself, changing your sector of work, or making some investment so that you can migrate or change sector of work, And again, here we're seeing very little. There's one statistically significant thing here. In a sea of insignificance, I wouldn't put too much weight on that particular thing. It looks like information does very little to change people's beliefs here. This is intentions for children. And again, we see very, very little here. Okay, I run out of time? Hopefully I'm exactly right here. So in summary, respondents already seem to know what's coming, at least on average. If that's necessary for them to migrate in an orderly way, that information is already available to them. They believe that climate change will be bad, but they believe that they can adapt without having to move across space. So that means they have a low intention to migrate. One thing our study is not set up to answer, no, it's not what we expected, is are they overly optimistic in their ability to adapt? And the only way we can understand that is by studying better in these locations how much people can adapt. What is the gain from moving to shrimp? How long lasting is that? Information has very, very little impact here, at least on average. This suggests that just getting information about climate change out there isn't going to change very much, although we're looking at the heterogeneity it impacts. Perhaps it's the place that people that were pessimistic to start with are brought down in their beliefs, and those who are optimistic to start with are brought up in their beliefs, and we haven't looked at that. Oh, and point 4 I already talked about before. It's unclear to me whether adaptation beliefs are overly optimistic or around about correct. So thank you very much, and thanks for listening.
Super. Thank you very much. Excellent, and really for taking us one step further in the discussion that Mushfiq kicked off, and for ending on time, which is amazing, on the dot. So our next speaker is Adam Storeygard, and Adam is an associate professor of economics at Tufts University. And Adam is here with us in person. Thank you, Adam. Over to you.
Great. Thank you so much for having me. Here,
this one here.
Right here. Yeah. Whoa. Great. Thank you so much for having me here today. So this is joint work with Vern Henderson, Boyan Zhang, and David Weil. And so I think I don't have to convince you here that climate change is going to have impacts on how the natural environment is going to be able to support lives and livelihoods over the next century. And lots of scholars have tried to think about the magnitudes of these effects, and that's essentially what we're going to do in this paper. But we want to do so in a little bit different way. We hope has some novelty here. And specifically, we're going to do it through the lens of thinking about population pressure on fixed local factors of production. Right? And one thing that it allows us to do is to think about climate change and population growth through the same analytical lens. So the first thing we're going to add here to the literature, one is to think about the importance of various aspects of climate by calculating their effect on the within country spatial distribution of population. We're going to do that using a large set of climate indicators from global climate models. So going well beyond just annual average temperature and precipitation to many other moments of the data. And then to put this into a simple macro growth model to try to think about the role of within country mobility. Which is like the part that fits a little bit more with this session, I suppose. We're going to produce some projections on the economic impacts of climate change at various different spatial scales. Broadly speaking, the general tenor in terms of who wins, who loses is going to be very similar to other work, but the quantitative predictions are going to differ substantially in some cases. The second thing that I alluded to briefly in my intro slide is that we think that this idea of population pressure is a useful lens here, and the way we're thinking of it, population pressure is something that can rise either when land quality declines, I'll be more specific what I mean by land quality as we go on, or when population size rises. And so in order to project that forward, we're going to, in addition to climate models, we're going to use population projections from the UN. And we know that the countries that we expect to see the most land degradation from climate change are also the ones that there's a lot of overlap between those and countries that we expect to see the most population growth. And in some sense, the punchline from putting these two together is that we see economic damages from population growth as likely to be larger across the range of predictions we have than those from climate change, with some caveats that I want to be clear about at the end. There's also potentially more uncertainty across different population models than across different climate models. So we got into this from noticing a lot of popular discourse that thinks about climate, the effects of climate change from, based on this idea of pressure on fixed land resources, like this Times article, which I believe is coming out of, in part, the Groundswell report, and around that time. Broadly speaking, this is related to literatures on climate damages. So I think this has already been raised, this idea of a damage today, the idea of a damage function relating loss of GDP relative to what it would have been in the absence of climate change to a given amount of climate change, right? We can do this can be done on various spatial scales, right? Broadly speaking, there are two different ways to estimate a damage function. Mushfiq already laid this out more clearly than I would be able to. So this is in his conversation about the cross section, the panel, and the long difference. I'll just say we're squarely in the cross sectional mode in terms of our methods here. But I will say just one caveat to that is that we're doing this globally, and we're going to include country fixed effects in our model, which allows us to ameliorate some of that correlation with unobservables, at least, but controlling for things at the country level, like institutions. Okay. On the population side, so people I don't think, talk about population damages per se, but of course there's a long literature related to this dating back with a ton of work dating back centuries to Malthus. So broadly, what we're going to try to do here is we're going to infer weights on characteristics that determine land quality by looking at current day settlement patterns. This is an approach we developed in a previous paper. And this is where I want to say, when I talk about land quality, this is what we found to be a useful shorthand. But when we say that, we mean also aspects of the air and water around you, most importantly, of course, the climate. Okay, so land quality includes climate in our terminology. I hope that's not too confusing. And then we're going to look at how some of these characteristics are going to change due to warming, right? Because we have projections for that. So empirically, what we're going to do specifically is we're going to think about a world where labor is perfectly mobile across grid cells within countries. People are going to move in the long run, right? This is for the cross section today. To equalize average products, and therefore population per quality adjusted land, which is just quantity times quality of land. Quantity is just square kilometers of land. We're going to model the quality of land as a function of a vector of geographic characteristics related to, for example, climate, and I'll talk more specifically in a moment. And then we can think about population density as being a function of these land characteristics, as well as country fixed effects that are going to be critical for us. We're going to estimate the effects of these geographic characteristics using Poisson regression for technical reasons that I'll refer you to our paper for. The country fixed effects are really critical here because they allow us to account for average differences across countries in terms of things like institutions, which we know from the growth literature are important, as well as just country averages in terms of population and geographic characteristics. And so what that means is that we're going to be estimating those betas, those weights on our geographic characteristics, using only within country variation in population density and land characteristics. So this is I think, a subtle point that I want to just emphasize briefly. So when I say, when you can read on our estimates of land quality, when I say something like the Netherlands has good quality land, we're not saying the Netherlands has good quality land because it has high population density. That's not the inference we're making. The inference we're making is that the Netherlands has good quality land because it has physical geographic characteristics that predict high population density within countries on a global basis using our global data. Okay. So then our measure of land quality is essentially just a fitted value from that regression, right? And so this last part over here in brackets is just a normalization constant. So we can calculate land quality in 2010 using our data from 2010 and our estimated betas. But then we think is powerful about this technique is that we can then play that forward using land characteristics to the extent that we have predictions for them, say in 2100, and predict future land quality using the same betas, but the new but the new data on physical geography characteristics. Okay. To do this, we need data on population density. We also take data on a bunch of characteristics we don't think are going to change by and large, things like elevation. And then a lot of where the action's really coming from is a bunch of climate characteristics that, as I said, cover many different moments of what we might think about by climate. So related to the thermal regime, the moisture regime. So not just the average annual temperature, but how that seasonality, but the seasonality of rainfall, where that extreme events are placed in the year, things like that, right? As well as year-to-year volatility in things like temperature. All of this is coming from the global agroecological zones data. And we're doing this for about 200,000 grid squares in 164 countries. So this is what our measure of land quality looks like for our historical period, which is the 30 years leading up to 2010. So places that, so the places that have high land quality based on this idea, that things that predict high within country population density on a global basis gives you places like the eastern United States, much of non-Scandinavian, non-mountainous Europe, the North China Plain, and the La Plata Valley, and other places, and the South Australia coast. Okay. For the future, so I said we're using 30 years of data for what's happening currently, and then we're going to use projections for the last 30 years of the century. We're going to do that by averaging across 5 climate models, those for which GAEZ has distributed data. We're going to do it separately for 4 different scenarios within each, associated with the 4 representative concentration pathways from the IPCC, right? Those numbers that range from 2.6 to 8.5 represent the increase in radiative forcing. And most of the results I'll show you here are going to be for RCP 8.5, the most extreme, but in the paper we have it for all of them. So this is what changes in land quality are going to look like in our framework for using, again, the RCP 8.5. So most places in the world are going to be worse off. That's in red. Oops. Although to varying degrees, and it's mostly northern places that are going to, and some mountainous places that will get better in terms of whose land quality, as we define it, will get better. Okay? So we want to be able to aggregate those things to units like countries on which we do policy. Broadly speaking, there's a bunch of different ways to do this, but the ones we'll focus on are doing it essentially area and versus population weighted. In practice, I'm going to show you area weighted results today. There's results in the paper and population weighted. In practice, they don't differ much. I think that's a surprising result for us. And below, as we go on, I'll talk a little bit more about what that implies about how these 2 assumptions relate to in a model about our assumptions about labor mobility within countries. Okay, so this is just a table aggregating up to continents, essentially what changes from historical levels of average land quality here across these different regions versus I'll just focus on this last column here for RCP 8.5. So just by definition, we've set the average land quality of the world to 1, the area weighted average. And so the biggest impacts are going to be a fall in average land quality in Africa by almost half, from 0.7 to 0.375. Oops, sorry. All other regions except Europe, which includes Russia in this definition, are going to see decreases, but not as large as the decreases you see in Africa. Okay. And these, so here I'm plotting changes in land quality, projected land quality between 2010 and 2100 as a function of log GDP per capita. So you see, some relatively rich and northern places gaining quite a bit in land quality, but most places losing, and especially most poor countries losing. Okay. Now, you might say here that we're generating these estimates based on an average global estimate of what land characteristics matter for where people live. That might differ, for example, between rich and poor countries, right? So one way of trying to get at that, how much that might matter, is to re-estimate our weights on those land characteristics only using data from poor countries, but then projecting, using those weights to calculate land quality for all countries, okay? So I'm not going to go too far into detail on this, but the broad point is that doing it both ways, so the original way is on the horizontal axis, and the one that only uses the relationship from the physical geography, population density relationship from poor countries is on the vertical axis, and you can see that they are highly correlated with, again, some outliers. So it does matter, that difference does matter for some countries, but broadly speaking, they're telling us the same story. Okay, so now I want to take these, so I want to think about how to map the population, what we're saying here about climate change into GDP, and also to be able to use the same framework to do that with population growth. And in particular, for both cases, we're going to think about baseline and alternative scenarios for land quality, right, which is going to be which can be affected by climate change, right, and population, which is obviously going to be affected by population growth. So we'll have for each of those, for quality adjusted land area, X, and for population, L, we're going to have a baseline and an alternative scenario. And in all of these comparisons, we're gonna hold constant everything else, things like productivity growth and investment rates, to focus on these two characteristics: the changes in land quality due to climate change and changes in population. So the details of the model in the paper, I'm just going to sketch it out very briefly here. We have a simple Cobb-Douglas production function in quality adjusted land, capital, and productivity adjusted labor. We don't have human capital in there explicitly. You can think about it as being in the productivity term. Physical capital is going to be perfectly mobile. And then the key question for, especially in this, I think in this audience, is whether people are mobile, right? And so we can think about this in a few different ways. So we know that effects of climate change are going to be heterogeneous within countries, right? So we just saw this in Bangladesh, but also in the US, right? We know some places might actually gain and some places will certainly lose more than others. And so that means we know that the effects of climate change are going to depend both on the spatial distribution of climate effects and of population, and how those two spatial distributions differ, right? And also whether people move in response to climate change, right? So the way we're dealing with this is actually evolving slightly as we revise the paper, but broadly speaking, we look at a couple different cases. So in one case, simple case, labor is perfectly mobile in the present and the future. In another case, we just treat the population distribution as fixed today and seeing what happens into the future, right? And the difference between these two scenarios in terms of the projections we get are actually surprisingly small. So I'm going to focus on the mobile labor case, and most of the details on the other cases I'll leave for the paper. Okay? So in that mobile labor case, just going through just the broad sketch of the outline, right? Free migration is within countries is going to imply that the marginal product of labor is going to be equalized across grid cells. So that means quality adjusted population density is going to be equalized as well. We're going to have capital accumulation solo. And then in order to solve the model, we're going to set our growth rates of output and capital equal along a balanced growth path. Okay? So what that's going to give us is an expression for per capita income, Y over L, in the alternative relative to the baseline scenario. It's going to be a function of the relative land quality in the two scenarios, the relative population in the two scenarios, and then a third term which we call offset, which relates to the dynamics of capital accumulation. That, as it turns out, it tends to be very small and doesn't actually matter much for the quantitative comparisons. When we look at the immobile population case, there's going to be a fourth term that's only going to matter in those northern countries that we expect might see benefits. So first, we want to look at the comparison just about what's going to happen from pure climate change effects. So we're going to hold population constant between the two scenarios at the 2100 value from the UN Population Division medium projection, and then we're going to compare a world with today's climate or 2010 climate with projections for 2100 from a climate model. So this is what we get. We're going to see incomes fall by as much as around 30% in all these countries in red and yellow, with some of the largest falls in southern Africa, and in some places in the north, potentially gaining quite a bit. This is again with the RCP 8.5, the most extreme climate change scenario the IPCC currently uses. Okay. This is where, as I said, surprisingly, the assumption about how labor mobility, what kind of labor mobility we allow for in the model doesn't actually matter that much. So for some relatively cooler places, it matters. They'll do better in the mobile labor cases, but for most countries, we get essentially the same results between the two. So now I've built up what's going to happen with what our model suggests is going to happen with climate change. So now I want to compare. I want to bring back in population growth. Okay, so we're going to compare base values for land quality and population for 2010, and then use projected values for land quality and population in 2100. Okay. And so here we're going to see is that, so again here we have the impact, this is the impact from those two changes, right? So population and climate on the vertical axis as a function of present day income per capita, or 2010 income per capita. So again, most countries are going to lose. This is the zero. This is losing relative to no population or growth or climate change are below this line. But there's this positive correlation, meaning that the poorer you are, the more likely you are to lose. And then I think perhaps this is the most striking graph to us. So here we're comparing we're splitting that back out into effects from population growth versus effects from climate change. So population growth on the vertical, climate change on the horizontal. Countries below median income per capita, in red, and above in blue. So so there's this kind of positive correlation here, and most poor countries are in this bottom left quadrant that would lose from both, and that is less true of relatively wealthy countries. So the countries this is when I say that the countries that are going to be really hurt by climate change are an overlapping set from the countries that are potentially going to be hurt a lot by population growth. Now these are all projections. So we know that there's a lot of uncertainty in these kinds of projections. So we want to think a little bit about how that uncertainty affects these, right? We're just going to do this in terms of what we can say across different population and climate projections. There's other work we want to do on thinking about adding more stochasticity into climate models. So basically here the UN population models actually have a distribution, which is really handy for us. There's no distribution, no one assigns, as far as we can tell, assigns probabilities to the different RCPs for climate models. So we just kind of have to take them as given, these four RCPs, right? And so here I'm just going to do this for one country, for India, and the way to think about this table here is that each number in here is a estimate of change in income per capita, from baseline to with the two changes, population and climate. And so comparing across columns in this row here is saying going from RCP 2.6 to RCP 8.5, there's about a 10% difference in GDP per capita, right? But if we go even just from the 20th percentile UN prediction of population growth to the 80th percentile, that actually gives us a 20% difference in growth, right? So that's when I say that there's a lot of variation depending on what you think is going to happen to future population growth. So that's what I want. So just to conclude, and then with just a couple caveats after these broad points I've said, we have this new method for estimating land quality, projecting climate change onto it, and thinking about this as an effect of climate change on GDP. Our estimates for the year 2100 under this most extreme climate scenario range a lot across countries. In the paper, we have some work on trying to aggregate this to the global level that requires some more assumptions. Impacts are correlated with GDP per capita. Poorer countries are hurt more. That's also true for population and whose effects we see being larger. Okay. A few important caveats just before to take home with this. So one is that we are looking at a specific set of climate factors that we have estimates on how they will change. our framework could be used to think about increased incidence of disasters, but we're not aware of any good estimates of what disasters will be like in 2100. So in principle, we could do that, but we don't have the data to. We can't really use this framework for thinking about sea level rise, which is important. So when I talk about climate change, I'm not really, what we're doing here, I'm not considering these obviously very important factors. We're also just essentially assuming that international migration plays forward like it has in the past. That's essentially what the UN population projections are embedding, right? On the one hand, you might think it might go up. It also might go down. And if you think if you know what's going to happen to restrictions on international migration, then you're smarter than I am. So we're not trying to touch that. And then finally, some people might look at our paper and say, oh, gee, this means that we don't actually have to worry about climate change. Population is more important. So even setting aside the caveats, like I said, we're not talking about important issues like sea level rise. We can't include that in our framework here. We don't think that is the right way to think about this. They're clearly both important. There's an ethical dimension to climate change, and it's also hard to think about the welfare calculus for having fewer people. So I may have gone over, so I should leave it there. Thank you.
Thank you very much, Adam. No, that really got us thinking and gave Esha Zaveri, our discussant, a daunting task to sort of drive us through and give us your reflections. Esha is a senior economist here at the World Bank and our global practice on water, and does lots of work on spatial economics, climate change, natural resource impacts. So she's going to lead us through a little bit reflections on what we've heard so far this morning. And then since we got a late start, I think we might still have a few minutes for questions from the audience. I have to look at my panel. They all look like they're ready to hang on for a bit longer. So as you listen, please feel free to think and be ready to come in with your comments as well. So Esha, it's over to you, please. Thank you.
Okay, sorry about that. Thank you so much, Anna, and thank you so much, Harris and Remy, for inviting me to discuss these amazing papers today. It's a real honor to be here, and it's a special honor to discuss these two stellar papers. And we've already heard so much from Mushfiq, from Adam, Gharad, so there's not too much that I can add, but I'll try and offer a few quick reflections. So I am from the water global practice, as Anna mentioned, and it's often said in the water sector that if climate change is the shark, water is its teeth. And everything that we do at the water global practice is therefore related to adaptation. It is at the core of everything that we do. And both of these papers that we saw presented today really push us to think about some of the key knowledge gaps and key outstanding questions in the adaptation space, which I think are especially critical. So what are some of these questions? So these were some that came to mind as I was reading the paper and the presentation that Gharad sent me. So one is, how do we manage global aggregate risk given the spatial distribution of risk and uncertainty? Even conditional on climate change or change being, say, 1.5 or 2 degrees, the spatial distribution of climate change we will observe is still going to be very uncertain. And Adam also alluded to another uncertainty, which is population growth. So there are many different dimensions of risk, and there are also different types of uncertainties. So how should society be valuing these different sources of uncertainty? Finally, we know from a lot of the empirical econometric evidence that there is a lot of uncertainty about estimates as well. So the uncertainty of estimates of climate change impacts, it increases as we move from the biological impacts, so for example, impacts on yields, to the economic impacts, which is impacts on GDP. And all of this will matter in how understanding the evidence base for all of this is really important in how we manage global aggregate risk. Understanding the causes of inequality and the role of income in the ability to adapt is also going to be extremely important as we start to project forward. The role of adaptation, some of the literature finds, doesn't really kick in for societies till you reach higher incomes. This is true for certain sectors, not true for all. In agriculture, a lot of studies find a limited adaptation. But in general, this is going to be very important as we project forward, because many of the populations in the future are still not going to be super rich in the next couple of decades. And so we really need to think of what resources people actually have at their disposal to adapt to the climate. And this is an important question that Gharad raised in his presentation. Finally, what will happen to migration? This is tremendously important and very challenging to understand. It's not just the agglomeration economies that we should be worried about, but it's also about how these migrants are going to be received at the destination. This will matter also for social stability and social cohesion. And relatedly, the combination of conflict and climate disasters on migration decisions is also going to be equally important. So the paper that we saw by Adam just now really presented us with a new method on estimating these climate damages. They measure the effect of climate change on within countries' spatial distribution of population to assign weights on different climate moments, and they look at many. And then they combine this with a macro growth model. It's a really grounded look at the fundamentals. It estimates the benefits of adaptation as well, so it incorporates mobility, and they give you, they provide us with very granular projections. So it brings together these ideas of natural resource congestion due to population growth that go as far as back as Malthus. You see the picture on the slide to your right. And writing a century ago in the Quarterly Journal of Economics in 1917, Huntington also argued that climatic shifts in the Mediterranean led to declining agricultural productivity and the eventual violent fall of the Roman Empire. And so the paper really brings together these two strands, the analysis of climate change and population growth in a single framework. The second paper by Gharad is telling us how much do people's information about climate matter for adaptation. It's very difficult to understand when people's expectation about climate has changed, but it's extremely critical to understand how people's understanding on climate matters for adaptation. And so here they elicit beliefs after providing forecasts on climate change and damages in order to study mobility decisions. And they move away from this perfect information assumption that is oftentimes embedded in a lot of the literature and the work that we've seen. So pardon me, Adam, if this is a toy diagram of your conceptual framework. But basically, the paper is trying to assess how these two forces, the changes in land quality that will come about due to climate change and changes in population growth together, will impact this degree of pressure on natural resources, and how this in turn is going to impact economic stress. But this is going to, the heterogeneity in that response is driven also by the mobility of labor in their model. And when I was looking at this and reading about this, it reminded me of this chart from a report that I co-authored several years ago. And what we've done on this chart is remarkably simple. We've just simply overlaid the fertility rate or population growth with the availability of water. And what we see in the areas of red is water scarcity and water stress spreading and intensifying. And most of these places where this is happening are also places that are often poor, where population is growing, places that are fragile and sometimes in conflict. So we really need to better understand the economic magnitudes that Adam explained in his paper and the geographic distribution of the climate impacts. So what they find is that areas that suffer the most declines in land quality are also places where population growth is increasing. Sort of reflects the chart that I showed before. And most of these are areas that are currently poor as well. The biggest driver of economic damages in their model is population growth. And labor mobility makes little difference to their damage estimates. So some comments that I had were, how uncertain are these population projections going forward? Of course, they point out in the report that the variation, in the paper, that the variation is large when it comes to population projections, and so they're likely to be uncertain as well. There are also many non-linearities and threshold effects, sea level rise, shifts in ecosystem services, that makes estimating future losses extremely hard. And what recent papers have done is use historical and natural climate model experiments from the CMIP-6 class of models themselves to estimate how much anthropogenic climate change has already affected the economy. Because we're already seeing these effects. The paper by Ortiz, Popia et al., for example, finds that in Africa, the world's poorest and most food insecure region, climate change has already reduced agricultural TFP, total factor productivity, by 34%. And this is getting more severe over time, and they see this only within the past 40 years. So it would be an interesting experiment to also look at create a counterfactual from using both the historical and natural climate model experiments. The paper by Gharad gave us some of the first evidence on climate beliefs and impacts. Again, as I mentioned earlier, it's really critical to understand how people's understanding on climate is for adaptation. What they find is that the people seem to be pessimistic about climate, but they expect to adapt in place. There's also less intention to move with information. The presentation that Gharad shared with me had some really tantalizing questions at the end, which won then the presentation today. But I was curious about some of the heterogeneity and exposure, because we know that some of the socially disadvantaged groups may be exposed more, and they could respond differently to climate changes. Of course, we had this presentation by Mushfiq as well, and so I don't have to go into this, but why is adaptation through migration not considered? And these channels of misallocation is really important to understand how to then effectively respond through policy. So is it sorting due constraints faced, land or credit? Could it be just different attitudes to risk? Immobility as a choice? Is migration seen as a failure to adapt? So with this, I mean the decision to migrate is occurring when they think that alternative adaptation strategies are not available. So migration could be seen as a solution of last resort by families because they perceive it being more costly, or it could be due to other constraints that they face. So I guess this is a really important question because it asks us, how do we increase the adaptive capacity of the poorest parts of the world? They consider a variety of climate moments, but I just wanted to point out there's also a lot of regional variation within the country that's driven by the country's topology. So there's groundwater depletion in the northwest, drought-prone areas, but there's salinity in the southern coastal areas. Also, groundwater change that is included in the climate moments they consider is a long-term change, and it itself is impacted by climate and other anthropogenic factors. So making a distinction between slow onset climate change versus sudden onset might matter too, because we know that different types of shocks lead to different types of responses as well. So I'd be curious to see if there was heterogeneity with respect to the different climate moments considered. And finally, I just want to end by saying that this was something that we discussed in a report called Ebb and Flow that came out 2 years ago that focused on water, migration, and development. And it was a sustainable development flagship, and we wanted to point out that when we think of policy choices and policy responses, we have to think of both the short term and long term. So an optimal strategy would really need to balance both the short run as well as the long run trade-offs. And this would entail improving rural rural productivity and livelihoods in the short run, because it is often the case that the rural sector supports the livelihoods for many. And we know that negative rural sector shocks driven by climate can spill over to the rest of the economy. And second, it entails promoting the long-term resilience of communities, especially when fixed factor supplies of a resource such as water can limit growth. And this, I would argue, is especially critical in places where people may become trapped and increasingly vulnerable to high climate risks like the Sahel, or where livelihood opportunities may shrink and become less sustainable in the long term. So policies that focus on reducing the climate risks and the impacts, which we should, they have to be complemented by strategies that also broaden opportunities for people. And here I want to make a point about education and which could act as a portable asset wherever people choose to locate. This is something that is also discussed in a forthcoming flagship report. Sorry, I'm throwing all these flagship reports at you, but this is discussed in a forthcoming flagship report on cities called Thriving, so look out for it. Ultimately, I think both papers tell us very strongly that we need a better understanding of the spatial distribution of risk and impacts so that we can target appropriate policies to the most vulnerable. So thank you very much.
Super. Thank you so much, Esha. Excellent summary. And I think it's going to have to stand because the better judged hosts of the event have told me that we're going to wrap it up, or I should wrap it up, because I think it's between you and lunch and us right now. So better judgment is that lunch may take over. Just a few final thoughts as we conclude. One, great presentations. I hope you all enjoyed them as much as I did. I really learned something. You left questions. There were several surprises in all of it for me. A couple things I walk away with, that idea that we need to get those local level impacts. So what does adaptation look like locally? What are the barriers to adaptation and migration? How do we understand issues like land consolidation? How do we understand the role that issues like income play, as Esha pointed out? How do we understand this issue of migration and conflict? And I think that's one of the things that I take away that I deal with on a daily basis is how do we bring in more of the ideas of community and culture and what that might mean to people's choices as they go along. And we see it playing out. How do we know when it's conflict or migration, climate change related conflict, and how that may play into the decisions that people make? And we're seeing a lot of that in my region alone. I think the three summaries at the end, Esha, were right on. Short and long-term impacts. How do we include this broadening, include what we think about in terms of climate change and migration, to also include understanding, creating broader opportunities for those impacted, as well as creating stronger resilience, and then getting really much more clear on that spatial distribution. So we can have broad knowledge at the country or regional level, but what happens at the level within a country makes all the difference in the world, and then the social implications for that. And finally, I really appreciate, I got a great new phrase today. Climate change is the shark, water are the teeth. I had not heard that one before. So thank you very much. Thank you all to our fantastic speakers here and online, and for you being a wonderful patient audience.